Far beneath the snow-draped peaks of the Alps, a silent transformation is underway, one that promises to reshape the way people and goods traverse the continent. Stretching 64 kilometers through some of Europe's harshest rain, this tunnel is poised to become the longest underground railway link in the world, surpassing even Switzerland's renowned Gotthard Base Tunnel. The project emerged from decades of mounting pressure on a critical north-south transit corridor, burdened by congested roads and overworked railways. Its mission is clear: to deliver a faster, cleaner, and more efficient route beneath the mountains, blending cutting-edge engineering with ambitious environmental goals. Twin tubes pierce ancient rock, joined by meticulously carved cross passages, built using some of the most advanced tunneling technologies ever deployed in Europe. But this tunnel is more than concrete and steel. It embodies a vision of integration, sustainability, and smarter mobility, while grappling with immense costs, technical complexity, and sky-high expectations. Will it be celebrated as a bold leap forward or remembered as an over-ambitious gamble etched into the Alps? Today, we explore the €11 billion Brenner Base Tunnel. Nestled on the Austria-Italy border, the Brenner Pass has long been one of Europe's most essential transit routes. At 1,370 meters above sea level, it's the lowest alpine crossing, yet its steep slopes and harsh winters have challenged travelers for centuries. Since Roman times, this corridor has been a lifeline for trade, migration, and military campaigns. Today, it forms part of the European Union's Scandinavian-Mediterranean corridor, a strategic artery connecting Finland to Malta through an integrated, multimodal transport network. By the late 20th century, the Brenner route was under strain. Over 2.5 million heavy vehicles traverse it annually, choking roads, polluting the air, and testing outdated infrastructure. The existing rail line, with its steep grades and tight curves, could no longer meet demand. Something transformative was needed. Austria and Italy, collaborating with the European Union, envisioned a high-speed, flat rail corridor beneath the Alps. A tunnel designed to shift freight from road to rail, redefining connectivity and sustainability across the region. The Brenner Base Tunnel stretches 64 kilometers, linking Innsbruck in Austria with Fortezza in Italy. The main section covers 55 kilometers, accompanied by a 12.7-kilometer Innsbruck bypass. Twin single-track tubes, spaced 70 meters apart and connected every 333 meters by cross passages, provide safety and maintenance access. Below, a third exploratory tunnel, originally carved for geological studies, now supports drainage, monitoring, and emergency access. Strategically positioned along one of Europe's busiest north-south corridors, the tunnel bypasses steep gradients and bottlenecks, offering a high-capacity, flat route for both passengers and freight. Designed for speeds of up to 250 kilometers per hour for passenger trains and 160 kilometers per hour for freight, it promises faster travel, reduce emissions, and less pressure on aging infrastructure. Turning this vision into reality required one of Europe's most complex tunneling operations. Construction began in the early 2010s with the excavation of the central exploratory tunnel, 12 meters below the main tubes. This allowed engineers to study the challenging alpine geology, fault zones, fractured rock, and high-pressure groundwater, and refine methods to prevent collapses and manage subterranean water. Once the groundwork was laid, construction of the main tunnels accelerated, with work advancing simultaneously from multiple access points. Tunnel boring machines carved through stable rock, while drill and blast techniques tackled less predictable sections. Some stretches, like the Isar River crossing near Franzensfest, demanded extreme ingenuity. Engineers froze saturated riverbeds to stabilize the ground before excavation. At depths exceeding 1,300 meters, workers contended with immense rock pressure and geothermal heat, reinforced by specialized ventilation and lining systems. By mid-2025, nearly 90% of the tunnel, including main tubes, cross passages, exploratory shafts, and service tunnels, was complete. Full operation, including track laying, system integration, and safety testing, is expected by 2032. With a projected cost of €11 billion, the Brenner Base Tunnel is one of Europe's most ambitious infrastructure ventures. Funding comes from the European Union, Austria, and Italy, with the EU leading via Connecting Europe facility, while national agencies cover the remainder. Oversight falls to BBTSE, a joint European public company, ensuring cross-border collaboration, accountability, and alignment with broader sustainability and transport goals. This tunnel showcases how large-scale international projects succeed through unified planning, shared responsibility, and decades of cooperation. Yet challenges have been immense. Complex geology, extreme depths, and hybrid excavation methods pushed engineering limits, while environmental groups and local communities voiced concerns about groundwater disruption, noise, and ecological impact. Critics argue the project is costly, invasive, and questions linger over carbon emissions from construction. Despite protests, minor regulatory hurdles, and rising expenses, work has pressed forward. Once operational, the tunnel will transform European mobility. Freight and passenger trains will pass through at remarkable speeds, cutting travel time between Innsbruck and Fortezza from 105 minutes to just 35. Around 1.2 million trucks per year will be removed from Alpine roads, reducing emissions, noise, and congestion for local communities. Fully electrified, the corridor supports long-term climate objectives while boosting trade, tourism, and labor mobility between Austria and Italy. Excavation nears its conclusion, and the tunnel approaches completion. Years of technical innovation, international collaboration, and careful planning are converging into one of Europe's most ambitious infrastructure achievements. Feeder links, especially in Germany, will integrate this marvel into the broader Scandinavian Mediterranean corridor, unlocking faster, cleaner, and more efficient transit across the heart of the Alps. Beyond the engineering marvel, the Brenner Base Tunnel tells a story of human perseverance. Thousands of engineers, geologists, and construction workers braved freezing winters, scorching summer heat, and the relentless pressure of alpine rock. Each meter drilled demanded precision, courage, and innovation. In every tunnel shaft, there's a tale of problem-solving under extreme conditions, where technology met the unpredictability of nature head-on. The tunnel is more than a shortcut. It's a lifeline for communities long impacted by congestion and pollution. Alpine villages, once isolated or burdened by heavy traffic, will now breathe easier. Local roads will be quieter, air cleaner, and the scenic landscapes preserved. It's a project where progress and responsibility collide, proving that large-scale infrastructure can coexist with environmental care when planned with foresight and respect for nature. Economically, the tunnel is set to be a game-changer. Freight will flow faster across borders, reducing costs and boosting competitiveness for industries across Austria, Italy, and beyond. Tourism will flourish as travelers zip across the Alps with unprecedented speed. Small towns along the route will see renewed investment, new jobs, and opportunities born from connectivity that was impossible just decades ago. Yet, the Brenner Base Tunnel is also a reminder of the scale and ambition required to reshape Europe's transport network. It challenges every assumption about tunneling, safety, and international coordination. It is an experiment in patience and precision, a test of what humanity can accomplish when vision, expertise, and determination align. As the final systems are integrated, signals calibrated, and tracks laid, Europe prepares to witness the culmination of over a decade of relentless effort. When trains finally roar through the twin tubes, they won't just carry passengers or cargo. They'll carry the promise of a new era of sustainable, high-speed connectivity. Looking to the future, the tunnel sets a benchmark for megaprojects worldwide. It shows how nations can collaborate, how engineering can confront nature's toughest challenges, and how ambition, when paired with meticulous planning, can create infrastructure that lasts for generations. The Brenner Base Tunnel is not just a path through the Alps. It is a bridge to the future, where speed, sustainability, and human ingenuity meet. And while it may be decades before the full impact is measured, one thing is clear. This tunnel has already changed the way Europe imagines crossing mountains. From freight logistics to passenger travel, from environmental conservation to regional development, its influence will ripple far beyond its 64 kilometers of underground passage. This is more than construction. It's a legacy carved in stone, steel, and determination. The Alps, once a barrier, are now a conduit for progress, proving that even the most formidable landscapes can be transformed when vision meets engineering. The question now isn't just how fast trains will move through the Alps, it's how Europe will move forward, connected, efficient, and ready for the challenges of the 21st century. The Brenner Base Tunnel stands as a testament: when nations unite, When ambition is tempered with care, and when human ingenuity meets nature's greatest obstacles, even the impossible can become reality. When complete, the Brenner-based tunnel won't just be a tunnel, it will be a symbol of ambition, cooperation, and forward-thinking engineering. For Europe's commuters, freight operators, and environmental advocates, it promises a new era of high-speed, sustainable, cross-border travel. This is proof that when vision meets unity, even the Alps can be crossed with unprecedented ease. What do you think about this incredible mega-project? Share your thoughts in the comments below. Thanks for watching, and we'll see you in the next video.